on well. In this lesson we're going to be looking at finding the length of an arc, and this is higher tier. So recap on what we learnt last lesson. We learnt the parts of a circle, and remember the arc is a section of the circumference of a circle. So I'm drawing that on here in red. So that is what an arc is. So it is part of the circumference, and that's going to be something that we will need to remember for this, is the formula for the circumference of a circle, which is pi times diameter. So to work out the length of an arc, we need to know what the radius is to be able to find out the diameter, and we'll also need to know, similar to when we were working out the area of a sector, we need to know this angle to be able to find the fraction of the part of the circumference that the arc is. So the formula for the arc length is going to be the fraction of the circle, which will be theta over 360, multiplied by pi times diameter. And that is how you find the arc length. Can you write those notes into your book underneath gwaith dosbarth dyddiad and then arc length, please? Okay, so once you've done that, we're ready to try out this example. Again, writing out the question and the answer. You are allowed a calculator for this, and you need a pen, pencil, and either a pair of compasses, or find something that is got circles. For example, if you wanted a coin, or if you've got a glue stick to draw around to draw that nice circle. Okay, so this is asking us to find the length of the arc. So the first thing that we do is we write down the formula. So arc length equals theta over 360 multiplied by pi times diameter. Now let's look at what we've got. We have been given theta, which is the angle, which is 30. So we'll substitute that in. 30 over 360 times pi times diameter. Now notice they have given us the radius. So the radius is 18 centimetres. We need the diameter, which is 2 lots of the radii, which then gives you an answer of 36. So here I need to put 36 there. So type that into your calculator, you'll get 9.424779, and because this is a length, we'll round that to 2 decimal places, put in the units and write down to 2 dp. It is as easy as that. Can you write that in, please? Then moving on to the next example. Now this one looks a little bit more difficult. It's more of a numeracy type question. In a shot put event, competitors throw the shot from the throwing circle into a landing area. The landing area is part of a sector of a circle of radius 25 metres. So here it's told us that the radius is 25 metres, but I would also draw that on here to show it a bit more visually. When it's at the centre point of the throwing circle. The sector angle is 35 degrees, that's drawn on there. A diagram of the throwing circle and landing area is shown below. Calculate the length of the arc AB. So we need to find the length of this. So they're testing us on the arc length. So first of all, as always, write down the formula. Okay, so theta over 360 times pi times diameter. Substitute in the values that you have got. So we've given theta is the angle, which is 35, pi times diameter. Now again, they've given the radius. We need the diameter, which is 50 metres. So it's going to be pi times 50, which then typing that into a calculator gives 15.27163095, which rounding it to 2 decimal places is 15.27 metres to 2 dp, and that would be your answer. Okay. Looking at this this example here then, the sector has an angle of 35 degrees, the arc length is 20 centimetres, find the radius of the circle which this sector came from. So this is a bit different, but they've told us what the arc length is. So we know that they're testing us on arc length. So as always, first of all, write down the formula for working out what the arc length is. Now let's substitute in what they have given us. They've given us the arc length to be 20. They've given us the angle, which is theta, which is 35. And they haven't told us the diameter. And we know that the radius, which is what we need to find, is half the diameter. Okay, so that will help us. So we work out what the diameter is and then half it to find the radius. So what we'll now do is we need the diameter on its own. So we're going to have 20 divided by 35 over 360 times pi. That would equals the diameter. Type that into your calculator, you'll get 65.48089087 is equal to the diameter. So that means then that the radius is going to be half of that, because it's half the diameter, which will give you 32.74044. And then again, as it's a length, we will round it to 2 decimal places and write the units there as well. So that's how you'd go about finding the radius. The important part there to take out the question is that it's given you the arc length. Finally then, I'm trying to find the size of the angle here. Now here it doesn't mention the arc length, but notice that they've given us that the arc length here is 21.6. They've given us the radius and they want us to find this, the size of this angle here, which I'm going to call theta. So they've given us the arc length. So again, this question is testing us on finding the arc length. So the first thing that I will do is write down the formula. So that we know that the arc length is 21.6. Theta we don't know, because that is what we need to work out. Times pi times the diameter. And notice this is the radius. So we must be careful. The diameter is 2 lots of the radii, so that's going to give us 19 centimetres. So the formula is going to be 21.6, which is the arc length, equals theta over 360 times pi times 19. So then, what I will need to do is, again, I need theta over 360 on its own. So I'll take these here, divide by those, so that's 21.6 divided by pi times 19, or 19 pi, is equal to theta over 360. Typing this calculation into my calculator, you'll get 0.3618680.811 is equal to theta over 360. So now, to get theta on its own, 360 times 0.3618680.811, we need to multiply it by 360, will be theta. So theta is equal to 130.2725092. So theta is equal to 130.27 centimetres to 2 decimal places. And there is one more question then for you to write into your book. Okay, it's asking you to find the perimeter of this shape. So to find the perimeter, we're given the radius of this sector, which is 3 centimetres. We know that this side here is 3 centimetres. The perimeter is the distance around the outside of a shape. So we need to find this length here. And this is an arc of a circle, so we need to find the arc length, first of all. So, as always, first of all we write down the formula. So this is going to be substitute in the values that you have been given. Be careful, they have given you the radius to be 3 centimetres. We need the diameter, which is 2 lots of the radii, which is 6 centimetres. So multiply by 6, type that into your calculator, you get 1.518436. Now I will round this to 2 decimal places now, because I know that to work out the perimeter, what I now need to do is add up all of these lengths here. So it's going to be 3, add 3, add 1.52, which gives an answer of 7.52 centimetres. And there we've answered quite a few different approaches where we need to use the formula arc length. So now I'd like you to hopefully try out the questions and do well. Well done.